Alright, let's evaluate the following limit. Limit as x approaches 0, x plus 8 to the power 1/3, which is also known as a cube root, minus 2 over x, right? Because we know that x plus 8, 1/3 can be written as the cube root of x plus 8, okay, right? And this kind of goes back to our exponent rule. X to the power a over b is going to give us a radical, x being the base, to the power of a to the index of b. And the index here is 3, so this is a cube root. Okay, anyways, let's try to look at this limit. Now you can notice here, just off the bat, as x approaches 0, you can see that the denominator becomes 0, right? So this actually identifies a restriction. So there's going to be a restriction here. It's going to cause the rational expression of this limit to basically be undefined. So we need a way to cancel out this x. Now, in this scenario, it doesn't seem like there is a solid method that is clear-cut. Like normally we would be multiplying the conjugate, however, this is a cube root and not a square root, so the conjugate just wouldn't work out. So this is where we need to employ a substitution, right? So this is kind of like a special case type of question. It's still pretty important to understand this kind of template in case it comes up on some kind of assessment. So in this sense, I can notice here that x plus 8 to the power 1/3 cubed is going to give us x plus 8. Okay? So this is going to give us x plus 8. So I'm going to let u equal x plus 8 to the power of 1/3. Okay, just to make it easier so we don't have to keep writing out x plus 8 to the power 1/3. And if I do u cubed, it's going to give us x plus 8. Okay, so that's what I showed here. And after I do this, we can notice here that the limit is when x is approaching 0. So I'm going to write x in terms of u. So you get u cubed minus 8 is equal to x. Okay? And in this case, as x approaches 0, so when x approaches 0, you can notice here that u cubed minus 8 will give us 0. U cubed is equal to 8. And if you cube root both sides, u here is equal to 2. Okay? So x approaching 0 is equivalent to u approaching 2. So I'm going to change this limit expression, which was in terms of x, now into the terms of u. So limit u approaches 2, right? So wherever you see x, you have to plug in u, right? So you can also notice here that x is basically u cubed minus 8, right? So for x on the denominator, we have u cubed minus 8. That's what we showed here, right? And on the numerator, we have x plus 8 to the power 1/3 is u, right? And you have u minus 2. And now you can actually see this is a lot of a simpler expression. Now we can actually factor this. Now if you look at u cubed minus 8, this actually resembles difference of cubes. So according to our difference of cubes, where we have a cubed minus b cubed, we can factorize this as a minus b times a squared plus ab plus b squared. Alright? So I'm going to do the same thing for this guy. So u cubed minus 8 you can write as u cubed minus 2 cubed, which is basically u minus 2, u squared plus 2u plus 4. Okay, so that's 2 squared basically. And now what you can do here is I'm going to plug this in, the simplified or the factored form, into my expression. So you get u minus 2 times u squared plus 2u plus 4. And now you can actually see that these two will cancel out, right? And you can also see that the denominator doesn't have a restriction anymore. So now I'm going to substitute, I'm going to let u approach 2, and you're going to get 1 over 2 squared plus 2 times 2 plus 4, which is going to give us 1 over 4 plus 4 plus 4, which is going to give us 1 over 12. So as the limit x approaches 0 in this expression, it's going to approach 1 over 12. We just created an equivalent expression to show that.